Okay, so test 11D, class 9 science, these questions. Okay, let's go to page 169 and start with question number 4. Page 169, open your textbook to that. Let me read the question. Certain force acting on a 20 kg mass. So I think we can start writing down the data that are given. So here, M is 20 kg. So this is the mass, okay. Then as we read on, we find the velocity changes from 5 to 2 meters per second. So the first one that appears 5 is initial velocity, u, 5 meters per second. Initial velocity, and then decreases to finally, that means the final velocity, the second one that appears. So final velocity, u and v are given. Calculate the work done by the force. So all done here. So let us start here. Therefore, since clearly the object is moving with 5 and 2 meters per second velocity, means energy possessed will be or work done will be the kinetic energy, calculation of the kinetic energy. So let's just write here initial kinetic energy. Let us say E kF, denoting EKF, denoting the initial kinetic energy will be half. Formula for kinetic energy is half mv square, right? We know that now. Since it's initial, we have to use the initial velocity, not v, but u square. So if we calculate this, we are going to get half. Mass is 20 kg. And u here is 5, so we can write here 5 into 5. Then square means 5 into 5, then square means this meter also will square. And the second to the power minus 1 will also become minus 2. So 1 into 2 square. So this is not sorry, this is meter per second square, sorry. So once we're done with that, then we can write here 2 tens are 20, then 5 fives are 25, into 10 is 250 you will get. So here kg meter square, let us break it up into meter. So kg meter per second square. Let us write that down first into this meter here at the back. We're just rearranging to show the unit of energy. This we know is the best unit of force, which is Newton, and here meter. And we know that Newton meter is the SI unit of energy, which can be simply written as joule, right? SI unit. So let us put this one as, okay, that is fine, I think. Then final kinetic energy, let us say E kF. So if we were to calculate this, there will be same formula, half m. Final means we'll use the final velocity v, so mv square. So they will give you here half. M is 20 kg and v is here 2. So 2 into 2 meter will become square because v square. So second to the power minus 1 also will square. 1 into 2 plus into minus, minus 2. So power will be minus 2 there. So like we have done a moment ago, 2 tens are 20, then 2 twos are 4 into 10, 40, right? 40 kg, and as I said, let us square this, meter square, let us break it up, kg meter per second square, let us write. And then this meter, let us put it at the back. So we're going to get here 40 kg meter per second square, the best unit of force, which is Newton. We can write in Newton, and the best unit can be changed to the normal SI unit of force, Newton, and then 40 Newton meter can be written in the simple SI unit, joule. Therefore, the work done, the question is asking this one, the work done. Go back to question and see. Work done by the force is equal to final kinetic energy EKF minus initial kinetic energy EKI. Sorry, this is initial kinetic energy. Please change it slightly. EK small I. So EKF just now we got here 40 joules minus EKI, okay, 250 joules. So minus 250 and then plus 40 means we subtract. So here 210, and bigger one is minus, so we're going to get equal to minus 210 joule, which is negative. So this means what? That is force that is acting here. Negative work means simply force x in the direction opposite to displacement. That means the object is moving from left to right because the velocity is decreasing from 5 to 2. That means a force is acting opposite to the movement. Displacement means movement of the object. Okay, so that is it. Okay, so that is your answer. Let's go to the next one, number 9. Okay, you can do slowly. So let us see that. Question number 9. Same page, I think. 169. So certain household consume 250 units of energy during a month. So how much energy is this in joules? So here, this is quite simple, I think. Energy consumed is equal to 250 units. So we have to change this 250 units to joules. So how do you do that? Now we know that unit means simply, in other words, kilowatt hour, kWh. So we can begin from there, and 250. Let us change this part here. We know that 1 kilowatt, the word kilo means 1000, we know that 1 kilowatt, okay, 1 kilowatt is equal to 1000, because this K means 1000 watt. So if you want to change kilowatt to watt, then you're changing big to small, so you have to multiply by this 1000. Then this kilowatt will disappear and watt will come in. This hour is okay, we just keep it like that. Then here, we next go here 250, then 1, 2, 3 more 0. We can just add it up, and watt here. We know that 1 watt is equal to 1 joule per second. Keep that in mind, okay? So 250,000 watt up to here will be 250,000 joules per second into hour. This one, let us keep it same for now. So next, I hope you're getting that 2540 joules per second, and we know 1 hour is 60 minutes and 1 minute is 60 seconds. So if you want to change hour to second, you're moving 2 places to right, means 60, 60. Big to small, so multiply 60, double 61, 2 movement to reach second. So hour will remove and second will come in. So this second and second will cancel. So we get here 6 6 are 36, and then 25 here, let us put, multiply 30, right? 5 6 are 30. Then 3 in hand, 5 3s are 15, 16 17 18, 12, 2 3s are 6 7, so 0 10 and 9 here. So we're going to get 900. 25 multiplied to 36, then 1 2 3 4 5 6 zeros, still left 1 3 4 5 6 zeros, then here joules. So this is your answer in joules. We can leave it like that, but usually they express in standard form, so decimal move from here 1 2 3. You don't have to mark like this in exam, okay? I'm doing so that you'll understand just by marking. You don't need to do this. 1 2 3 4 5 6 7 8 places you have to move if you want to bring the decimal right after the first digit. So you have moved 1 2 3 4 5 6 7 8, means you have to multiply by 10 to the power 8. This is called standard form, and then that means bringing the decimal after the first digit of the extreme left, okay, right on the right side of the extreme left. So you can answer this way or this way also, but usually textbook answer this way, okay? So that is your thing. Now we'll continue the next 2 questions in the next class, okay?